Awesome. Everybody hear me okay? Hopefully you are all here because you have a manufacturing facility and you're looking for efficiency improvements, or maybe you own IT, OT infrastructure that powers critical line processes for your business. Maybe you are here just because you're under pressure to use technology to improve your processes, save some money. If any of those reasons sound about right, you're in the right place. I'm Matt Reed. I'm a senior solutions architect with AWS, and today we're going to be talking about AWS Outposts and your ability to harness the cloud right at your on-premises edge. First, a little bit of context into the situation and circumstances that we all find ourselves in. Everybody is looking to technology to improve their existing processes, however possible. Research and markets study says that in the next 5 years, we'll see a 4 times increase in the spending just in these areas alone. Probably you're looking at some kind of like operational efficiencies or speeding up time to market for your design and engineering cycles. You're not alone in this area. Specifically getting into manufacturing, these are the trends that we hear from our customers, divided into really three buckets. Folks looking at low latency requirements. This thing keeps going forward. Low latency requirements, compute at the edge for local data processing. Maybe you're looking to take advantage of real-time analytics. Maybe there's AI ML inferencing to improve your local line processes. And you want to improve kind of your resiliency posture. Any of these areas that anybody here is evaluating at all, looking at compute on the edge or AI ML inferencing, anything like that? Okay. What is stopping you from getting into these areas? What are some of the challenges you're seeing? It's possible that you have critical processes, robotics, or safety concerns, and you need single-digit millisecond latencies to be able to feel confident. Maybe your connectivity is such that you're just not yet confident to put your data in the cloud because you don't have the right resilience posture or failover setup. Maybe you have legacy infrastructure that requires a lot of coordination and dependencies and lead time to coordinate and change, and that's just a little bit more than you're willing to take on your own. Today, there is a solution that will begin to help you address these challenges. And that's the AWS Outposts family. AWS Outposts are a fully managed service that brings the same infrastructure and services that you are using currently in the AWS cloud to virtually any on-premise edge location. Gives you a very consistent hybrid experience. The form factors of AWS Outposts are available in a full 42U rack. That's really designed for your own data centers or co-location facilities. And then there's the smaller 1U and 2U servers, and these are for your local regional offices, maybe clinics, restaurants, or smaller scale manufacturing facilities. What can the AWS Outposts do for you? It's, as we noted, you're using the same command line interfaces, the same SDKs that you do to build and deploy your modern cloud native applications across the web. You can be running them also locally on-prem. Determine your own management plane for your APIs, set your governance policies, security controls, automation. It's all available to you with the added benefit of having that fully managed service from AWS, meaning you don't have to patch, you don't have to update. We'll come in and take care of that for you. Most recently, AWS has released the Generation 2 Outpost rack, and there's a few significant features that have been added. Really, the architecture for the networking has been completely reimagined, so there is now decoupled networking from your compute droplets, meaning there used to be a one-to-one requirement, but with the Generation 2 Outpost, now there's a single networking stack that handles all your compute. So really increases your cost efficiency and your flexibility to deploy. You can spec out your racks maybe at some percentage fill, anticipating your growth, and then do the infill requests. AWS comes in, shows up, adds them for you, so then you don't have to guess for your capital expenditures, and that's one of the advantages of the fully managed service there. Also, the networking resilience posture has been greatly improved. It's now can handle device failovers inherently, which adds to your resilience posture as well. And then connecting is easier now, more easier than ever with the Outpost, because you can do things like our domain routing groups, which allow you to choose your routing for local direct VPC for your containers running on the edge, which is typically important for your performance. But then you can also use your own IP blocks using a COIP setup for some of the AWS services like RDS requires. If you want to do multi-availability zone for fallback, you need the COIP routing. So those are some of the new features, make it easier to connect with the new Generation Outposts. The Outposts are available in many different locations. You can see in the green, there's where the first Generation Outposts are still available, and the orange is places where you can get both first or second generation, and there's always more being added. Lastly, just want to emphasize that AWS leads in this area. According to the Gartner Magic Quadrant survey in 2024, AWS ranks first in all four of these areas: hybrid infrastructure management, edge computing, assured workloads, and AI ML. With that, I will turn it over to Vinny, who will take you through the Rivian Outpost journey.
Thank you, Matt. Hey, everybody. My name is Vinny Makachek. I work at Rivian as a senior staff AWS solutions architect. Our team's responsible for managing our entire AWS estate across all of the business units. Today, we'll talk a bit about how Rivian is using Outposts, some of the challenges we had with implementing Outpost, some of our lessons learned as we're trying to move our manufacturing workloads from really what's a legacy kind of stack to something much more modern that gets us the cost efficiencies and gets us the operational efficiencies that we're really seeking, right? So about us, if you haven't heard about us, we build electric vehicles, including trucks, SUVs, commercial vans. Our vehicles are super connected, have an amazing software stack. And actually, if you ordered something on Black Friday, one of our vehicles might have actually been involved with delivering your package to your home as an Amazon delivery vehicle. Tactically, some of the things that are important to us as a company include technology leadership. Again, the software is everything in our vehicle. It's a really unique experience. I highly recommend, if you haven't tried one of our vehicles, please get behind the wheel of one. It is absolutely amazing. I see someone smiling in the second row as we talk about this. Obviously, the technology drives demand generation that gets more people interested in our product. And obviously, that all helps. Using good technology will help us get better efficiencies, lower our cost, deliver a better product. And of course, if you've ever heard our CEO, RJ, talk about this topic, we're really trying to enable experiences in a sustainable way. And that's something just really unique to how we view our role at Rivian. So now that you know a bit about us, some of our challenges, right? As you might be aware, automated manufacturing has been around for a very long time, lots of technology, a lot of it's legacy. So we definitely had a lot of legacy VM-hosted stacks that existed in our on-prem data centers that we had to work with. We really, really love containers. We have a rock star Kubernetes platform team at Rivian. Because of the legacy VM stack that our manufacturing workloads were using, we couldn't actually take advantage of any of that expertise that we had in-house on how to deploy, manage, operate, and scale Kubernetes workloads. Of course, skill silos, right? Two different teams had to learn two different skills. They couldn't help each other in on-call or rotation or when something went wrong. And then, of course, maintaining availability on a legacy VM-based workload, super difficult. You have to patch. Well, how do you coordinate patches? I have to turn the server off, right? I have to take downtime in that model. And so this really, as you can imagine, was very challenging as we're trying to get those operational efficiencies in our business. Some workloads, what kind of workloads are we running? We're running manufacturing execution system. That's our orchestration engine, our messaging engine that helps coordinate all of the activities at the plant. We're also doing industrial automation. So we have welders and all sorts of really cool robotic tools that make our cars, that make different components, put them together. All of that has to be automated using industrial automation tools. Of course, we're very technology focused. We're using AI, ML, computer vision. If you name it, we're trying to integrate it into the process in order to, again, drive those customer outcomes. And so a lot of smart people at Rivian said, hey, this isn't working for us. Let's try something different. And so we went and we tried Outpost. And so what we did, we took our VMs, we snapshotted them, we moved them onto Outpost, we maybe deployed a couple of RDS instances, we said project is a success. Boy, were we wrong. Some challenges that we had, network resiliency. If I have one complaint about the Outpost service, I really hate the name. The name is a misnomer. I think people picture Outpost in their head and they're like, I'm in the frontier, I'm with a kangaroo somewhere. And in reality, Outposts really require network connectivity back to that region to provide all of the great services and orchestration, all the value you expect to get out of Outpost in your data center. You must architect for network resilience when you're using Outpost. Obviously, an application recovery strategy, kind of similar. You should know your failure modes on your new hardware, on your new platform. And we didn't do a really good job at that. And then, of course, lack of standardization. As I said earlier, we want to be on containers, right? We want to be on a much more modern stack. And we kind of just took our problem and we moved it to a different place. And the ultimate result of that, we lost trust internally. And then we had to kind of reevaluate what we were doing. And so a bunch of smart people got together. We said, hey, let's try to do this on our own. And we built the MCP, the Manufacturing Compute Manufacturing Container Platform. It was a kind of combination of various vendor tools. If you've ever purchased IT hardware for an on-premises system, you know you go to one company to get storage, you go to a network vendor to get your network kit, you go to maybe a hypervisor vendor to get either Kubernetes platform as a service or your virtualization technology, and then you kind of have to get them all to talk together. They're not inherently designed as one comprehensive, cohesive thought, but they're disparate systems that need to work together. And that can be kind of hard. Challenges we saw, ticket hell. Every different component's owned by a different vendor, owned by a different team, and well, they all have to talk to each other, right? So when I have an incident, who do I go to get root cause on what's causing this incident? How do we remediate it? How do we make our vendors work together in order to deliver the value we're expecting out of our platform? Obviously, capacity planning, we're still stuck in racking and stacking and purchasing and procuring and purchase orders and all of the things that add no value to our customers. And we have to plan ahead. It takes sometimes 6 months, a year, to get the correct equipment into our data centers from inception to delivery from our vendors, right? That's not scalable as we're trying to build out our R2 platform, our R2 lines at the normal facility. And then, of course, again, no standardization. It's a Kubernetes platform. If you've ever used EKS and then tried to move that EKS workload to a non-EKS Kubernetes platform, there are differences. Things like IAM roles for service accounts aren't there, right? Just some of the bells and the whistles that you expect aren't going to be in that environment. And as a result, It's kind of like a death by 1,000 paper cuts. There's enough differences to make it sufficiently different that you can't just port your workloads from the cloud to on-prem. And so that means that now we have to do development on-prem. We have limited capacity and space and power and cooling. And now instead of being able to take advantage of the cloud and just go boop and move it onto our on-prem environment, lo and behold, we're kind of stuck with this silo again. So our future solution, we have decided after much consternation, we went back to the drawing board. We took all of those smart people. We said, hey, how can we do this better? What did we do wrong with the first two goes at this? And we realized that we hadn't architected for resilience. We hadn't actually architected our outposts in a way that would be productive for our business. And so we've decided to go all in on Outpost Generation 2 for our manufacturing workloads at our normal facility. This is a very simplified diagram of what we deployed. A couple of key callouts. Previously, we had used, so an outpost requires service link connectivity back to the region to make all of that orchestration happen on your behalf for the infrastructure. We previously had used the public internet in order to do that. So we connected to a public endpoint out our front door and went up to the region. That's not very resilient. There's a lot of internet weather that comes in between. And so as a result, we've gone with Direct Connect. We have a Rivian backbone that connects to a major data center provider, and that enables us to connect to the AWS region in a way that is redundant and reliable and secure. And of course, we're using EKS. So now we'll have that feature parity. We'll be able to benefit from the deep expertise of that Kubernetes platform team. They're actually advising in the migration project. And so kind of to review our journey, mid-2020, we start Outpost Gen 1 POC. Someone says, hey, I want an Outpost in our data center. We order it, we rack it, we stack it, we move on to it, right? Late 2021, bad things come in threes. We have 3 separate network outages for 3 different reasons in 3 months. And one results in a really painful line down event. We lose a lot of trust. One of them was caused by a Christmas tree being installed at our facility. Of all things, they hit the fiber. Truly, you can't make this stuff up. Move on to 2022 to 2024. We went back and we tried to do it ourselves. We learned a lot about what we were good at and what we weren't so good at. And then late 2024, we kind of reevaluated. We said, hey, let's actually have a bake-off. Let's see what the experience would be like on these different platforms. And then we coalesced. We had consent. We came together. That's one of our Rivian principles, compass values, to go all in on Outposts for our manufacturing workloads at normal. Outcomes and benefits, I think you guys understand. Consolidation, portability, low latency, cognitive simplification, right? Like we want one platform that our entire company uses. That platform right now is AWS for a lot of our workloads. And so this is just a huge step improvement over what we had previously. And kind of to summarize in the last minute our lessons learned. Architect for resilience. Capacity management is still important on Outposts. You do need a certain amount of lead time. It's less, frankly, than our traditional vendors, but you still do need lead time to get more capacity. So building out reporting dashboards so that you can see what the capacity you're consuming is on your Outpost, what do I need to order, kind of trying to project as much as you can, as much as your business allows you to, what your capacity needs will be. And then the middle point, RAM sharing VPCs. Outposts are a finite set of resources. And as such, they utilize a finite amount of power and cooling and ultimately CIDR. I highly recommend, do not create 800 VPCs. Create one VPC, share it out. It's in one data center. That will create a huge reduction in operational overhead for your team. And then most importantly, trust is hard earned, easily lost, and difficult to reestablish. You got to earn trust with your internal customers as well, right? And that's the most important thing. So thank you guys for letting me come up here and tell you about our experience with Outposts, and I hope you all have a great day.
Thanks very much. If you have any questions, we can meet you around the side.